Hi everyone, this video is to go over lesson 4.3. I'm going to do this lesson in two parts. So video 1 will go over the first derivative test, and then I'll do a second video for the second derivative test. Okay, so the topic of this lesson is going to be looking at how derivatives affect the shape of a graph. So when we don't have the picture of the graph in front of us, what can the derivative, the first derivative and the second derivative, tell us about the actual shape of the graph? And then in the next lesson, we're going to be using the derivatives to actually graph a function. Okay, so the first derivative test can tell us a lot about, or we can search for maximum and minimum points using this test. Okay, so let's just look at the pictures. I think it makes more sense than the words in the box there. I'm going to zoom in a little bit closer. Okay, so let's look at the first example. We have a graph that's in blue here. When you take the derivative, remember the derivative is the slope of the tangent line, right? So a positive slope means the graph is increasing. So if I were to calculate the derivative of this graph in this portion of the graph, it would have a positive slope. That's why the derivative here is positive. Yeah. So I'm going to use yellow for positive just because yellow reminds me of happy. Okay. And on this side of the graph, the derivative would have a negative slope because the graph is decreasing. And so that's what's written here. I'm actually going to use a lighter blue because that kind of erased. There we go. Okay. So notice then the point in between where it switches from yellow to blue, from increasing to decreasing, we've got a peak, right? At this point here, the derivative would be 0. And it would be a local maximum point on our curve. So wherever your derivative switches from positive to negative, you've got a local maximum. If you have the opposite scenario, so your derivative is negative or less than 0, your graph is decreasing, and then it switches to increasing or a positive derivative, then in between at that point where it switches, you've got a local minimum. Okay, it could be the case where you don't have a minimum or maximum at all, though. So in this scenario here, you've got a positive derivative, and then the derivative is zero at C, and then it's positive again. So this is not a maximum or a minimum point. And then also here, you've got negative derivative and then a negative derivative. Okay, just to be clear, the C is the critical number that you would be searching for. So remember last lesson we found those critical numbers? That's what C stands for here. So let's say you found a critical number. Then you're going to calculate the derivative on either side of that critical number, and you can get any one of these 4 scenarios. And in this first scenario, you would have a local max. In the second scenario, you would have a local minimum. In the third scenario, you would have neither, and same with the fourth scenario. Of course, you're not going to have the pictures in front of you, though. So we're going to do an example where we don't have the graph in front of us. We're going to search for those critical numbers, and then we're going to do this first derivative test and see where the maximum or minimum points on the graph are. Okay, so we've got a nice sort of simple parabola here. First thing to do is find critical numbers. So remember, critical numbers, there's 3 types. Endpoints, which we don't have in this scenario. They don't give us any endpoints for this graph. Places where the derivative is 0 and places where the derivative is undefined. So we need to find the derivative. F prime of x equals, okay, so the 4 is going to come down, and that's going to cancel with the 1/4. So it's going to be 1/4 times 4 times x cubed minus, and then 3x squared. Simplify that because the 1/4 and the 4 cancel out. So it would be x cubed minus 3x squared. Okay, so now we're going to search for critical numbers. So we want to know where this is equal to 0. minus 3c squared. Okay, so to find the zeros here, we need to factor, and there's a c squared in both terms. I'm going to factor that out. Okay, so there are two places where c is equal to 0, or where this equation is equal to 0. One is at equals 0, and one is at c equals 3. Again, c, remember, stands for critical number. That's why I'm using c instead of x, just so that we don't mix them up. There are no places this is a polynomial, so the derivative is always defined. So then there's no endpoints. So these are my only two critical numbers here. Okay, next thing we're going to do is the actual derivative test. Now, to set up the derivative test, a nice, easy, clean way to do that is to make a table. Okay, so we're going to be interested in 2 points and also the derivatives surrounding those 2 points. So my table, I'm going to make it 1, 2, 3, 4, 5, 6 columns long. You'll see why in a second, and 3 columns deep. Okay, so along this line, I'm going to put some x values. So I'm going to be interested in equals 0 and c equals 3, but also the values of x equals 0 and x equals 3. But also the values of x surrounding these points. So I'm going to look at the area of the graph to the left of 0. I'm going to look at the area of the graph between 0 and 3. And then I'm going to look at the area of the graph greater than 3. Okay. So we're going to be looking at the derivative here. We already know the derivative is 0 at those 2 critical numbers, but we want to know what the derivative is before and after those critical numbers to figure out which of these 4 scenarios we're in, right? So right now we have these critical points, these red dots, but we want to know which of these 4 cases we have. Okay, these are the only 2 places where the derivative is 0. So to figure out what's happening with the derivative for x less than 0, we just want to know whether the derivative is positive or negative. So to do that, we just need to pick a test point. Anything that's less than 0, we can just test it, plug it into the derivative, and tell whether the derivative is positive or negative. Pick a nice number, like for example, -1. If you plug -1 into, let me just use an equation here, f prime of -1, for example, is, if I plug it in here, I get -1 cubed, which is -1, minus 3 times -1 squared. So I get -4. That means all the derivatives less than 0 are also going to be negative. I don't really care what the actual value is. I just care that it's negative. Okay. So I'm not going to write this test down every time. I'd like to just do it. I mean, if I need to use a calculator, that's fine, but I'd like to just keep that in my head. What I really care about is that that is negative. So the function is decreasing as I come in towards x equals 0. Okay, at 0 we have 0. At x between 0 and 3, so I'm going to pick another test point. Let's say 1. So I'll write the test values for this one example, but again, you don't have to write them. So let's pick 1. That's between 0 and 3. That's a nice number. So I'd get 1 cubed minus 3 times 1 squared. So I'd get -2. So again, we have a negative value. Okay. There we go. And then I just need to pick one more test point greater than 3. So let's just pick 4, for example. Get 4 cubed, which is 64 minus 3 times. Okay, this is where I'm going to need my calculator, because I'm not the best at mental math. Minus 3 times 16. So I get 16. So that's a positive number. That means since the derivative is positive, the graph is increasing. Okay. So let me just explain what I did there. We looked at the two, we're interested in the points of the graph surrounding these two critical numbers. We already know the derivative is 0 at these 2 points, right? For x less than 0, we used a test point, plugged it into the derivative, and found it was negative. So that means the graph is decreasing in this region. So I'm just going to use, oops, forgot. Okay, so remember blue was for negative going down. The graph is also decreasing in that region. Okay, and then the graph is increasing in this region. Okay, so now I'm just going to write down what I found out. So the graph is decreasing in this region. The graph is decreasing in this region. And the graph is increasing. Oh, that moved where my highlighters were. Let's just change those then. Okay, so I'm just going to kind of draw that as well. So the graph would be going down and then further down, and then over here it goes up. Okay, so now I can tell what these critical numbers are, if they're maximums or minimums. This first scenario, let's just look up at our derivative test. If I'm going down and then further down, I don't have a max or a min. I'm in this fourth scenario here. So this is not a maximum or a minimum point. Okay, or because it's not a y value. However, this scenario, we're going down and then up, it's going to be a valley. This is going to be a minimum point, local minimum. That was scenario 2, right? So if you're decreasing and then increasing, at the bottom would be a local minimum. Okay, so that's how you find local minimums or maximums if you don't know anything about the function and you don't have any endpoints. We don't know whether this is a local minimum or a global minimum. We just know that it is a minimum. Okay, so I'm just going to write a conclusion here. According to the first derivative test, f of x has a local minimum at x equals 3. Okay. And again, it could also be a global minimum. But we would have to sketch the graph to figure that out. And we'll do that in the next lesson, okay? So let me just show you the actual graph itself just to check. So if I was you and doing this assignment, I would have Desmos by my side. So here's the graph we were interested in. We were looking at these 2 points, 0, f of 0, and those were our critical numbers, 3, f of 3, right? And we found 0 was not a maximum or minimum, right? Because it was decreasing and then decreasing. And then this was a global minimum because we were decreasing, but then increasing afterwards. So I'm just going to take a photo of this and put it into the notes. Remember, you can get these notes later. You can print them off if you want to from OneNote. Okay. If you want a picture of that, you can add that into your notes. So we can see there it actually is a global minimum as well. So we found the derivatives here, negative and negative because the graph is decreasing, and then positive here. So we have our minimum point at x equals 3. Okay, so that's the first derivative test. It helps you find maximum and minimum points and tells you where the graph is decreasing and increasing. Okay, so I'll make the second video about the second derivative test and post that separately.